So we look today to the Scala. We're looking to the Scala, and which is going to be the continuity of where we have left from. In this Scala, we are, let me share that also. In this Scala, which we have here, we saw that the Scala was a new language which was developed to support the interoperability of application created in Java or created in another language to be able to be accessed with the hardwares. So Scala, there are so many frameworks which you can find, you can use to create your web, let's say a website and so on. Previously, we saw that the Scala, it's a stand for scalable language. The base language for this was made in two, or it's made in two ways. I mean, it's having a root in a two concepts. Number one is object-oriented programming language. Number two was what? For those who are in the class, function, right? Functional language. So they combined the two languages to make Scala. So which can become scalable language. I mentioned in my previous class that Scala is 100% object-oriented programming language. Why? Because everything is treated as a class. We shall see how this Scala and the classes, work together. And also it has the concept of function, means breaking things into functional or methods. So that we look in our today's lab or exercises. So in this part which we have here, in this part of Scala, right. So in this part of Scala, we saw the two hypotheses. The two hypotheses which you have seen. Number one was God to create a language which can better support the component software. And we need to find a language which is very compatible to be scalable. When we say, remember, we have learned in our first class something called scale up. We have to scale up, right? We have to scale either horizontally or vertically. Means what? When we scale, means what? Add on, right? You can add on either, you can pipe up horizontal or you can pipe vertically. So Scala is a scalable language which can be expanded, which can be used in many operating systems, in many software, in many hardware as well, can be compatible with it. So that was the first hypothesis. And also we mentioned all these things in our previous class. So we saw the features of Scala. We saw that Scala is both functional and object-oriented, and everything in Scala is treated as an object. And remember, just today, maybe I'll have to remind you that any object has what? An object has the state and the behavior. Object, any particular object which we have, it will have state and behavior. What does it mean, a state? State means characteristics. Example, you take a man or a student. A student is an object. State can be what? A name, an ID, a height, a weight, nationality. This can be known as a state. Behavior, student study. Students take tests. So these are the behavior. Behavior, in other words, they are known as a method or function, in other words. So here, everything in Scala is treated as object. So that's the first thing to understand. So this is an example This is Scala. Everything is treated as an object instead of, treat them as a primitive type. So this is the way we saw the history of where Scala came from in 1997, where they developed, where all the language, Java, but Java was developed in 1990, 1991, 1994, 1991. And they find that the software is not compatible with the main operating system. Then they create something called JVM. What JVM stands for? Java Virtual Machine. Right, so let me try to make it here. I think I made one point here just to highlight about JVM, because Scala is built on JVM. Scala is built on JVM, or use the JVM concept. Let me share this as well. So let's try to understand the concept of JVM, right? Let's try to understand the concept of JVM. In this JVM here, getting the concept of JVM, let me expand it here. All right. So in the understanding of Java Virtual Machine, or JVM, I just want to show you how this JVM, supports, was the first, was introduced, supported many languages here. I'll take like 2 boxes here. All right, so let me take this one. I consider, let's say, this one which I have here. Let's say you write a program in Java. Let's say you write how do we write the program in Java? I give an example. In Java, how do you define the main function in Java? Is it a void?
Yeah.
Main, right? String args, right? Things like this, right? We open void static, right? Void static main. Static main string, things like this. So let's select it. Hey, what is the select? What is the move? I just want to point out this one. Okay, so this is a class. Let's say this is the all right, so this is the class. Let's say this is the main class which you have here. Let's say you write here. Let me carry on here, no problem. Okay. Oops. Let me carry on there. Let's say here we write and we say int a. Let's say a is equal to 7, and then we say print ln or system out. Let's say, sorry. Here we say system out dot, is it system out dot println? Yeah, let's take it up that way. So we print line, we say we want to print a. We print a. We print a. And we close this one semicolon, and then we close our main method. When you write this program in Java, just understand we're looking here, just for your orientation, for the things which I want to mention here. We are looking to the, here, we are trying to look to the, JVM, okay, or Java Virtual Machine. Why do we need it? That's the main concept, the main point which we try to analyze or to study now before we proceed in this Scala, right? So now we write the program here. When you write a program like this way, this program which you write here is known as, let's say this is, you will store it in your RAM. Let's say this program, you give the name as, let's say program one. Program one, that's the file name which you give, right? Program one, let's say dot, is it Java? Let's say Java. You save it in RAM. Let's say this program would be saved in your local machine. Let's say it is in C under Java program. You save it like this way. It's in a C, and then you save it in this way. This is the file which you have. Now, let's say this is the file which you store in your program. Now, this program, there are certain things which you need to do in order to print the line on your screen. Number one, you need to compile. Let's say you need a program need to be compiled, right? A program needs to be compiled. And then after compiling the program needs to run. Now we can run the program or execute a program. Start execute. After comparison, after compiling, right? You compile. I mix I here. I think this is, you compile. So in Java, a program needs to be compiled, and then a program can start to run. So to do this, JVM plays important role. To do this task, JVM plays important role. It takes this program which is written here. It takes this program, and then this program need to be this program need to pass to one part which is known as a compiler. So it's going to come here to the compiler. Sorry. This is going to come to the compiler. Let's take this as a compiler. It comes here to the compiler. The program which you write comes to the compiler. Compiler. So you compile the program. So once the program is taken to the compiler, compiler is going to do the following. Compiler is going to, where is down arrow? Yes. Compiler is going to change your program into something which is known as a bytecode. This is going to be bytecode. This is going to be bytecode. So when the program is changed to bytecode here, as you can see here, we take the program which is written in Java, let's say Java program and so on, right? So compiler change the program to bytecode or to the language which your operating system can understand. This one, you see here, it's program 7 Java, .java, right? So here, this bytecode will be changed to something known, let's say, program one will be program one dot class. So it will change to the class. Look the extension. There was Java. Here it becomes class to be executed. So this part which we have here, is supported, or it's carried out by something called the JVM. Where are you? Where are the symbols? Right. So all these things which we have here, let's just make them here. All these things, all this stuff which you have here will have the name of code, JVM. JVM is the man behind it. So it's Java virtual machine to convey the program written in Java program saved in the Java, compare it, and it's going to be changed into class which you created. So this concept is very, very important in Scala, even in Java programming language. So there are certain programs which are not compiler programs, they're interpreter programs that you can study them and check those programming language. So this is a part of Java virtual machine, the way the Java virtual machine can do. So that's what we're looking to this point here, looking at the language, Scala language on a JVM, right? So this program which you write here will change into JVM. So we saw the history, we saw that these companies which we have here, we saw different companies which use JVM or which use Scala. So many companies which, developed using JVM. These are the different, logo, different, different big companies which are behind using like a Twitter, Syrup, Sony, they all, prefer to use Scala. All right, so why do we need Scala? This is what we have seen here. It's object-oriented programming. This was the main part here. This was the main part here, right? And this functional. These are the main. The rest, like agile and the self-performing, these are the attributes which you can say. So this is one of the why Scala is useful. Yeah, that's this is the main, object-oriented. This is object-oriented and the functional as well. So these are the features which support agile, lightweight syntax, very simple to do, safe performance and strong statistics and so on. Now, this is what the people have said. For example, James Gosling, who created Java, as I mentioned, he says, if I were to pick a language to use today other than Java, it would be Scala. So that's what he mentioned. And Charis Nata, the creator of JRuby, he mentioned Scala, it must be studied. Is the current hail up, apparent to the Java throne? No other language on the JVM seems as capable of being a replacement for Java as a Scala. And the momentum behind Scala is now unquestionable. While Scala is not a dynamic language, it has many of the characteristics of popular dynamic language. Through its rich and flexible type system, its sparse and clean syntax, and its marriage of functional and object paradigms. I love this one, right? So it's marriage between functional and object paradigm. So these are what people have said. So the creator of Groovy, what did he say? I'm honestly say, if someone has shown me the programming in Scala book by Martin Odisky, Lex Spoon, and Bill Venners back in 2003, I would probably have never created Groovy. So they gave us so beautiful, cuts or, like attribute to this Scala language. It's a very sweet and a very nice. So before we look to the exercise of Scala, Scala, we need to understand certain basic syntax, which I'm going to write here. I think I have not written here in this PowerPoint presentation here, right? Check here. So we have a loop. I have not written them. We have only the classes, but the important ones are not written there. Let me make them clear so that you can have the enough grasp on this. So in this part, let me bring once again my note here. Just want you to help me to find what is the mode of text. Okay. No problem. Let me do this. All right, so now this was about JVM, right? So now let's see the basic syntax of Scala, okay, from Scala. Basic syntax of Scala. Okay, so let me minimize this so I save my space. Or for the sake of this, let me. Why it distorted? Let me put it here somewhere. Let me put it in this file so that in case if you need it, you can get reference from it. I think you need to come before that one about JVM. Remind me to send you this updated one. Here it is. So you will find in this note, you can give the title. I just put in a PowerPoint so that you can easily find it here. Okay, so now let's look at the basic syntax here. I'll call this one. Oops. So here, we look to the basic syntax of Scala. In the syntax, I mentioned here as a syntax or something which we need to understand or to have the meaning of Scala. What do we need to have here in Scala? Number one, the very first thing to understand, or the very first point to understand in Scala is that Scala, Scala, the first point here, I mentioned like the first point, Scala is case sensitive. Sensitive, right? Scala, the very first point to understand, it is a case sensitive. I give an example. Let's take an example. If you take an example, let's say, if you say, let's say, take an example of this one. If you say int is a far different, it's opposite from saying, let's say, it's opposite. I just want to draw one line inside it. So, okay, so it's far different from saying, int, right? Or if you say object is a different from saying, is a different of object with a small letter. So it's a case sensitive. So that's the first point to understand. Second point to understand about Scala, or the second syntax to understand about Scala, it's the classes, the class name. These are very important. I want you to pay attention on them, right? The class name. What does it say about the class name? In Scala, just one right here. In Scala, let me increase the size of this one. In Scala, all classes are started or are all classes are started with capital letter or or uppercase, or we may say here the uppercase, right? I give an example. Let's say take an example. Have an example. If you say, let's say this is a class name. Let's say the class name. Let's say the class. Let's say class. Let's say student. Right? As you can see, S should be in a capital letter. This S which you have here is a capital letter. Is a capital letter. That's how the class are written. The first letter should be capital letter. Or again, you say class, my, let's say my class. So the first letter should be what? Should be in a capital letter. All right? The first letter should be in capital letter. That's the second point to understand in Scala. Let me put it here. Right? This is the first thing to understand in Scala. Okay? And another point to understand here. Why is not? Okay. Another point to understand here in Scala, it's a program file. Another point to understand here, let me write here. Program file. You remember when I was explaining to you about the program file, any program which you write is going to be as a file stored in your file, right? Any program you write is going to be a program file, right? Now here, the program file. What does it say about the program file? Now, the name of program file stored in your disk should or must be the same as of your must be the same as of your object or class. Here, look the example. Look here. We have an example. Student is a class. So the file to save will be named as student. Right? Should be same as a student. Look there. Student we have there. And now here, example. I give an example here. I just want to dot here. I say example. Let's take this example. Oh, okay. Take this example. Oh, yeah, I typed here. Oh, why is it omitting? When I press to the tab, oops. Oh, how to redo? What is the redo? Huh? Oh, okay. Oh, what is the select? I don't see the select. In the top. I don't see select. Okay. Is it here? Open. Move. You help me, please save me. I just want to, to find the save. Okay. Now the content which was there, I cannot undo it. Oh, yeah. Why? See, I cannot undo it. Very bad. Okay, fine. I'll repeat once again. What did I say about program file? Okay. Program file. Yes. The name of what? The name of program file in your disk should or must be the same as object or class. All right, so we take an example. We use the same example above. The class name, let's say class name is student, right? Class name is a student. Let's say object name, let's say we have the object name which is called course. Now the file name would be course. Now here, file name, if you save them, file name would be student only, or it would be course as it is written. Remember, object and class should be started with a capital letter. These are examples. All right, so these are the examples of taking this one. Another aspect here, another aspect in Scala, right? Another aspect in Scala. I just want to highlight this one. Make it bold and increase to 14. Another aspect in Scala, it's this as follows. It says def main. Def means what? This is okay, def main. This def main, it is the main method or function. It's a main method or function. Means each Scala, each Scala program starts from this main function. So it starts from this main function. That's another fact you need to know, because it has to have this main function. Any class which you create, it has to have this main function. So it's written like this way: args column, we say array. We forgot array in our previous example of Java, and then we say string argue. I give you a task for you, just for your curiosity. What does it mean, this? Okay, you need to understand. What does it mean, this? Array, string, why do we need to pass that? So please, you find by yourself, check. It's very important to know. Right, so the next part, which we need to understand. All right, here, it's all about the main function. I may call here main method, I may call here main function. All right, I may call this as a main function here, and then we save it. Okay, we save it. Right, another part here, which we have here, is a method name. Method name. This is another point, which is gonna be the last. And then after the break, we start exercise, the lab exercise. So what does it say about this one? Just want to mention here. No, before that, we look one more data types. So, because it's important, without data type, we cannot be able to achieve a lot. So what does it mean about the function? Now, all method name, or method names should be should be started or begun with what? With a lower letter or lowercase, right? Class object should start with what? Upper, but this one is lowercase. right? This one we use the lowercase. We take an example. I was going to do tab. We say example. In this example, you take an example of the lower class or the lower method. Let's say def. Def is a starting of the method. You say def, and then followed by, let's say, my function. You see here, M is a lower. M is what? Lower, starting. This is a keyword. Def is a keyword to create a method. Scala is a sweet language, please. Spend the time, to learn it. All right. So this is the first part or the main thing which you need to know about Scala. And just for the sake of time, let me see. All right. So the next part here. The next part. Yeah. Scala date. All right. Right, it's a break time. So, all right. So now after the break, we come and look the variable, something we need to know about the variable, and then we start the lab session. Today, I want to end this Scala so that we can start the actual Spark or actual context which you need to understand. I mean, the way we have to use the Scala in a big data. This is a prerequisite to understand the next phase which we're going to look. All right, so go take your break, then we resume after 10 minutes. Brother, any question as you take your break? No question? Now we're going to look to the practical side, but before we go to the practical side, I mentioned that there are certain things which I want to introduce to you, such as the data type and the variables, because these are the foundation of every programming language. Without understanding the data type or the variable declaration, you can do nothing, right? So now let's look to the variables and the data type which are supported in Scala. Okay. Think. Oh, okay. I just want to select it. What is the move? I just want to check. What's the move? I forgot where is the move. Move instead of talking. There's no move in this pen.
No, you can't move the text, so you have to use this. You have to move select.
Yeah, that one is pro, right?
That?
Oh, it's moved. Okay.
Yeah, you just use select.
Okay, thank you. I was trying to. Okay, because normally there's a move sign like this, symbol. Great. Okay, let me send that side. Okay. So if I now, where is it?
Sir, if you move it out of the canvas, you can't get it back. Unless you undo it.
So it's a cut.
Yeah, that's all.
It's a cutoff. That's what I was wondering. Because actually move it, you can. Okay, fine.
Once you move out and just now what he do is just select everything and just move.
Just instead of
So if you move out, you cannot select that anymore. So you cannot move it back.
Yeah.
And you have to undo. Yeah, zoom out.
Okay.
And you can just extend the.
Okay.
size.
Okay, that's this the best option.
Yeah.
Let me zoom out and then remain there. What if I want to zoom out? Okay, great. Okay, this is the best one. Thank you. This is it. If I want a zoom out. Excellent. Yeah. Learn new now today. All right, so let me keep increasing the board in this way. So now we look to the another content here. Let me keep zoom them. This is the last. Okay, so it has a limit of zoom. This is the minimum zoom. All right, so here we look to the next part here. Sorry. Which I named to be as, oh, very small. Oh, when you zoom the board, everything becomes small, Mr. Zudawe.
Yeah.
You just zoom it back and you can just go.
You can zoom in. And use the scroll button on the bottom in the right.
What is it?
Oh, there.
Okay, sorry, it's okay. So here we look to the variables. Let me increase the size to the. All right. Here we look to the data type and variables. So in a Scala, we have the following data type. So what is a data type? Data type defines or specify what kind of data to be stored. Example, you could, for example, you want to store the names. Let's say names are string type, string or character type. Age are number or numeric type. Heights are fraction part or float type is and we may have even a double type. We may have a double type when the number becomes big. Right, so we have we have even a Boolean type. The Boolean type is used to accept true or false conditions. So that's a Boolean type. So these are the data type which you can have. And also in this data type which you can have here, integer, the data type integer, they contain 32 bits, or 8, is it 4 bytes or 4 bytes? It's a 4 bytes. When we talk about short integer in a numeric, the short integer, they are 2 bytes. Let me make the same formality. That's 16 bits, which are equal to, say, as a 2 bytes. We have another one which is called the byte type. The byte type is 1 byte. It's 8 bits. It is 8 bits, which is equal to 1 byte, which is equal to a byte, right? And we have a long int. We have the long int. The long int, they are equal to, or they have 64 bits. They are 64 bits is equal to 8 bytes, right? They are 8 bytes or 64 bits. 64 bits, which is equal to 8 bytes. We have double. I just put together here because they are same. Double and long integer, they have 64 bytes. And certain things such as character, important, interesting part to know here. The character, these are the numeric one. So let me mention here, these are the numeric data type. These are numeric data types. So in the numeric data types, we have all of this. We have all of this. So all of this. And if we look to the string type, this is also numeric. If you look to the string data types, in a string data type, we have the following. We have string as a data type. We have character, car. The car has the character has 2 bytes. It is a 16 bits, which is equal to how many bytes? 2 bytes. All right. You can also have one more, which is known as a null type. Null type symbolizes that is it's empty garbage value. This is a null type. You can also have one more type, which is called any type. It can support any type. You can have any type, to accept all kind. You can put all types. The Boolean, true, false, right? It's a true or false type, as I mentioned above there. So these are the important data types which you need to get, which you need to be familiar with them. So where this come from? Where's the string? I mentioned about something string. Where is it? Where is it gone? String type was here. It's missing. Car, 16 bits. We have also string type, right? String type. So this is Okay, so this is it. So these are the data type which we may need to use. And another part here, which I want to mention, which is also important to help us to understand how are we going to move in this one, is a variable declaration. Important point, variable declaration. Variable declaration. What is a variable? What is a variable? Variable is that holds. Right? So variable can be known as a container which holds a value, right? Variable is a container which holds the value, or which holds the value, or what is, a sign, or which holds a value, or which holds a value of a data, or the variable can be known as it reserve the memory into, this space into the memory, right? So that's the one will be enough, right? Which holds a value. So, okay, so now when we want to declare the variables, there are two things which you need to understand, right? Variable, I say variable, the variable can be declared in two ways. Variable can be declared, in three ways. The first one, a variable can be declared by value. Second, this is very important. Second, a variable can be declared by variable. Third, a variable can be declared by constant, right? Constant. Now, you may wonder what is this difference, right? Here, I start number one. Value. The value, we write it, we write it as a var, right? We declare variable by using a var. This var is known as immutable. This is known as a immutable. What does it mean, immutable? Immutable means it does not change. For example, the law of God are immutable. Exodus 20, they're not changed. So immutable means no change. Important point to understand. Means no change or modification to assigned value. Okay, you cannot change it. That's very fast concept to understand. Number two, when we say var, variable, or we use this one var, this one is immutable. Means can be changed or modified. So we can change or we can modify by using this var. Constant is it's remain the same. So these are the two main points, two main important to understand in variable. So to declare a variable, we declare a variable either by var or by var. Okay, so or you declare a variable by var. Both are same, right? So these are the two types, right? So yes, so these are the two important points to understand. Now, how do we declare the variable here? So this is the way we declare the variable. So this is one is like, let's say, example. I give an example. Take an example. You want to declare your age. You do as this var, let's say age, right? A name, var, name, right? So you can assign, let's say var name, let's say the name is going to be Winia. Important point to understand here. One more important. Here I put here. Scala does not force, does not force this symbol. What is the symbol? Semicolon. Does not force it. You can either put it at the end of the line or you cannot put it. So it does not force you. Okay, this is important to understand. So that's why here at the termination does not force at the end of line, right? So we don't need to put it in a Scala. Point to understand. So these are the important point to understand. The rest of the things you're going to see in the lab session. Any question about this?